Or let's look at the following limit. The limit as x goes to 0 from the right side of 1 over x. Okay, so let's recall some things. So first, let's recall, what does this limit symbol mean, right? And it means two distinct things. So what are the two distinct things that this limit symbol, limit as x goes to 0 from the right side, what does that mean? We can use chat or voice. Positive. Okay, good. So x is bigger than 0. I'm going to write that as the second thing. Right, that's what the plus sign means. X is bigger than 0. What's the other thing this means? Approaching from the right. Well, that's the same thing. Approaching from the right means the same thing as x is greater than 0, right? Let's see. Muhammad says close to 0. Okay, that's what I'm actually looking for. So x is close to 0. Both of these things are actually important. So now let's think about what this is supposed to mean, right? This whole thing. So keep in mind, what does the limit mean? The limit means, all right, as x, if x is positive but close to 0, what can you say about the values of 1 over x, right? That's what this limit is supposed to be telling you. So let's kind of write that down. Right, they're huge, right? In fact, they're more than just huge. So let's see. So as x goes to 0 from the right side, what happens to 1 over x? So the values of 1 over x, so first of all, they stay positive, right? If x is positive, 1 over x is positive. So that's important, that the sign is positive. Okay, so that's one thing we'll note. The values of 1 over x are positive. And they get arbitrarily large, right? That's what it means to go to infinity. That's what Margaret said. And they get arbitrarily large. What does that mean to you? What does arbitrarily large mean to you? Like when I say that, what are you thinking? Does arbitrarily large just mean just really big? What exactly does it mean? Can we say another way of describing arbitrarily large? Significantly huge? What does significantly mean? Numbers close to infinity? Well, how can it be close to infinity? Is infinity, first of all, is infinity a number? So we are going to write this. We're going to write this as plus infinity, right? Endless. So these values are endless. The values are not specific. What does it mean for the values to be endless? And what does it mean for the values to be close to infinity? They're just very big numbers. Okay, so like you can have 0.000001, etc. Well, that's arbitrarily small, Caleb. I think you mean the opposite of that. The values are approaching infinity. Well, that's not really saying anything because that's just saying it's kind of rewriting the limit. Never stop getting big. So arbitrarily large means the following. Arbitrarily large means if you give me any number, let's say 100 million, 100, 100 billion, whatever, you give me any number, the values of 1 over x will eventually surpass that number as long as I take x close enough to 0. That's what it means to be arbitrarily large. I can make the values of 1 over x as large as I want, as long as I take x to be as small as I want. And in particular, arbitrarily large does not mean, or rather, maybe you can explain this to me. Arbitrarily large does not mean the numbers get bigger and bigger. Or I should say, I mean, it does mean that, but it's not the same. This is not the same as the numbers get bigger and bigger. Now, as you think about that, I want to point something out. So this infinity symbol, infinity is not a number. There's no such thing as close to infinity or the numbers are near infinity. There's no such thing as that. This infinity symbol is just a symbol, and it literally means exactly what I've written down here. So when we say a limit is equal to infinity, what we really mean is that in this case, as x approaches 0 from the right side, the numbers are positive and arbitrarily large. That's what plus infinity means. So in particular, technically this means the limit doesn't exist. But by convention, we don't, if I asked what is the limit, what is this limit, you would not say does not exist. You would say plus infinity, right? So that's the convention we use in math. But strictly speaking, the limit doesn't exist because this infinity symbol is not a number. It's actually shorthand for this English sentence. So just keep that in mind. Infinity is not a number, and do not treat it as such. And now let's get back to this statement in red. So I'm trying to distinguish between numbers get the phrase the numbers get arbitrarily large and the phrase the numbers get bigger and bigger. Now, if the numbers get arbitrarily large, clearly the numbers get bigger and bigger, right? The orange does imply the red statement, but not the other way around. Can someone give us an example that shows that numbers can get bigger and bigger without getting arbitrarily large? Can someone give us an example of that? Like 10x? What do we mean by 10x? 10x is just an expression. Those aren't numbers. So Camellia says 1.001, 1.01, 1.11. Well, the numbers are getting bigger and then they got smaller. Let's see. Kevin says y equals x. The numbers keep getting bigger. Again, y equals x is an expression, so I don't see what numbers you're talking about. Aya says 10, 100, 1000, etc. Well, if I follow your pattern, I assume you're just doing powers of 10. But those numbers get bigger and bigger, and they get arbitrarily large. I want an example that shows that numbers can get bigger and bigger without getting arbitrarily large. Again, a straight line is not a list of numbers. I want a list of numbers that get bigger and bigger without getting arbitrarily large. What does that mean? Well, that's what I'm asking you. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, those numbers get arbitrarily large. Square root. Okay, so let's look at some of these examples. So 1, 2, 3, 4, 5, 6, 7, right? Just all of the integers. Do these numbers get arbitrarily large? Yes. These numbers get arbitrarily large because if you give me any number, let's say 100,000. If you give me any number, eventually the numbers in my list will surpass that eventually. That's what it means to get arbitrarily large. Do the numbers also get bigger and bigger? Yes. The numbers keep on getting bigger and bigger. They increase. So this list of numbers gets bigger and bigger and arbitrarily large. Now I want a list of numbers that gets bigger and bigger, but not arbitrarily large. So what about 0.9, 0.99, 0.999, 0.999, and so on? So question, and the pattern is supposed to be the obvious one that I just keep on adding more nines in the next number. So question, do these numbers get arbitrarily large? Why do they not get arbitrarily large? Right, they're never going to surpass 1, like Camelia says, like Thomas says. They stay under 1, right? So if I give you the number 1, do my numbers ever surpass 1? No, they never surpass 1. So they do not get arbitrarily large. Do they get bigger and bigger? That should be a fifth 9. Yes, right? One number is always bigger than the previous one. So that is the difference, that I can have numbers that get bigger and bigger, but do not become arbitrarily large. There is a difference. Okay. So the first list, this list of numbers, 1, 2, 3, 4, 5, and so on, that is really what kind of captures this idea of infinity, that these numbers will eventually surpass any other number. And that is the difference between numbers that are just big or numbers that are just increasing and numbers that are truly get arbitrarily large. That is the difference between them. Okay. All right. So now let's just look at another similar limit. Let's go back to limits. So what if I had this instead? What if I had the limit of 1 over x, but now x is going to 0 from the left side, right? What is the difference? If x is going to 0 from the left side, x is close to 0, and now x is less than 0, right? That's the only difference. X is negative. How do you think this is different from the previous example? In the previous example, the numbers got arbitrarily large, but they stayed positive, and looks like Thomas and Jessica have already written it. Right? In this case, if x is getting smaller, 1 over x, again, is getting bigger. The only difference in this case is the numbers are negative. That's the only difference. So the numbers do get arbitrarily large, but they go negative. So if you were to give me any negative number, no matter how big that negative number is, the values of 1 over x will eventually surpass, or maybe surpass isn't the best word, but they'll eventually surpass that negative number in size, right? They'll eventually get less than that negative number. Okay. So how in general should we handle this? Right, what was the idea of both of these? The idea of both of these limits was that if x, the intuition was if x is small, 1 over x is big. I mean, that's the intuition, right? The reciprocal of a small